And so what I want to talk to you about today is a philosophy that we have kind of really come to believe in at Gantry, which backs how we build products with LLMs, and is also built into our product, which is an analog to test-driven development for large language models. And so what I'm going to do is I'm going to kind of talk you through what that actually means and kind of how could you actually even test large language models. And then I'll show you a demo of how you can do it in Gantry. So a little bit about us off the bat, just to introduce myself. My co-founder, Vicky, was an engineer at OpenAI in the early days, built basically all of their infrastructure. We're backed by some awesome investors. But more to the point, so I want to kind of ground us in what it feels like to build applications with this crazy technology today in June 2023. So how many have built something with an LLM before, like an app or a demo or some sort of product? Yeah. So vast majority of folks, right? And why is that, right? Why is everyone experimenting with this stuff? Well, I think one reason is that the gap between your idea and having a prototype has never been shorter. So in 2023, if I have an idea about something I want to build, like let's say I want to ask a question of my Notion database as a Slack bot. Well, all I have to do is just Google that, and there's probably going to be a LangChain template for it, right? So I can just download this code and get started, and like 15 minutes later, I have a demo of asking questions of my Notion database. It's like amazing, right? Something that you couldn't even imagine doing 2 weeks before that. And so I think a lot of us, when we try this and get the first demo done really quickly, get kind of the wrong idea about what the rest of the process is going to be to go from that initial demo to something real, like an actual product that we can, that our users can rely on. So I think in our minds, the way that this works is, we built this whole thing in 15 minutes. And so the rest of this is going to be easy too, right? We're going to get our LangChain demo, and then we're going to do, some stuff. And then eventually in like, I don't know, a week or two, we're going to have some really powerful app. Maybe it's even AGI, right? But as you all have, who have played with this are probably familiar with, it's this phase in the middle, which is, what do you do after you have that demo, which is really where all of the difficulty is in building applications with AI today. And the reason for that is that, LLMs are these incredibly powerful primitives. It's this, almost like this alien technology that's landed on Earth. And it's unlocked all of these things that people, were really difficult to build before even 6 months ago. But there's a lot of challenges in building with these models as well. So, I heard about this term prompt engineering. And so, I heard prompt engineering, and I kind of thought that maybe this is going to be something that felt like engineering, but I actually think, calling it engineering is really, at best, like, let's say generous. It's more like prompt hacking. And then once I built that prototype, I played around with it a little bit, but I had no way to really know if it was actually working, if it was actually solving the problem that I wanted to solve. And I kind of came to the conclusion, like, is it even possible to test these things, right? How do you know if this application is going to produce the right output? So the upshot is building demos with LLMs, and this has always been true in ML, but it's especially true with LLMs, is a long way from building reliable production systems. So if our goal is to build an actual application that's powered by this technology, we need something more than just the tools to build that first hacky demo. So what I want to talk about today is what we think is potentially a better way, a philosophy that you can use, a methodology that you can use to go from that first demo to something that actually works. And what this looks like is kind of a lot like the test-driven development process in traditional software. So imagine that you have built that initial LangChain demo or LLM demo, and you're ready to test it. So you give it to your friends. Your friends start to give you feedback on how this thing is actually doing. Like, hey, did this answer the question correctly? Is it spewing nonsense, or is it saying things that are actually sensible? Then as a developer, you take that feedback. You use that feedback to understand what are the opportunities to make this application better. So you iterate on the application. And then once you have a version that feels like it's better, it seems like it's better to you, what we want to do is we want to systematically evaluate whether that's actually true, whether we've really made progress on this application or not. And then if you have, then you bring your team in to approve those changes. You deploy the new version, your users interact with that version, and you start this sort of virtuous cycle all over again of gathering feedback, generating new test cases from that feedback, improving your model, and then validating that the improvements actually worked. So this is kind of the subject of what we're going to talk about today. And so the first thing I want to do, the next thing I want to do is talk about kind of, I think, the sort of hairiest question of all this, which is how do you actually measure Like, how do you evaluate models? How do you measure whether the new version of your prompt or the new model is actually better than the one that you had before? So why is this difficult? Or why does this even actually matter, right? So if you've used LLMs before, you can get these like amazing first results, right? Where you ask it something and it does something really cool that you didn't think it could do. But then as you play around with it more, you realize like, hey, these things make a ton of mistakes. And so the implication of that is just because the new prompt that you wrote or the new model that you picked performs better on a few examples, the few that you cherry picked to test it out, does not mean that it's better in general. You can make a prompt better, you can make a model better on the handful of examples that you care most about, and it can get worse in some other way, in a way that's really, really hard to predict and really hard to understand. So if people rely on your model, if you're building an actual product with this model, not just a demo, then they're trusting you to maintain your performance on their task, the thing that they care about, not the thing necessarily that you as the developer care about. So that's why this matters. So in order to understand like how to actually do this, I want to kind of ground us in how we used to test models, back in the day when deep learning was like sort of the technology that everyone was using to build state-of-the-art AI systems. So the old way that we thought about testing machine learning models, and how many have done like trained models and done sort of more traditional ML stuff before? Okay, very small fraction. Interesting. So the way that this worked is you had some data that you trained your model on, and that data came from some like abstract distribution of data. You could think of this as like all of the possible points that might have come from this data set that you trained your model on. And within this training distribution, you have your actual training set. So this is the data you fed in to train your model. And then you had your evaluation set. So you held out some data from this training distribution to use to measure the model's generalization beyond just those data points that you trained on. And so you then would take your metric, like let's say your accuracy or whatever metric you care about for your use case. You'd measure that metric on both your training set as well as this held out data that you didn't train your model on. And the reason that we do that is because the difference between those two numbers, the difference between the performance of your model on the data it was actually trained on and the performance of your model on data that looks like what it was trained on, is a measure of how much your model is overfitting to those individual training points. Then there's often a gap between the data that your model is trained on and the data you actually needed to work well on in production. So you can then look at two similar data sets from your production distribution. You can look at your test set, and then you can look at your actual production data from your end users interacting with the system. And you compute your accuracy again on those two sort of data sets. And the difference between those numbers also tells you something about how the model is doing. So the difference between the performance on your evaluation set, so this is held out data from your training distribution, and your test set, which is data from what the model is actually going to look at in production, that's a measure of how much domain shift there is. So how different is the data your model was trained on from the data it's ultimately going to be evaluated on in the real world? And then lastly, the difference between performance on that sort of held out data set from your production distribution and your, the data you're currently seeing from your end users live in prod, that difference is a measure of drift. So how different is your performance now than when your model was trained? So this is kind of how we think about evaluation in the world of traditional ML. Next, I want to talk about why this doesn't actually work for LLMs. So like, why aren't we just talking about this same framework for evaluating LLMs? First, okay, most of you are, I'm guessing, using a model from OpenAI or Anthropic or Cohere, or maybe you're using an open source model. But even if you're using an open source model, I'm willing to bet that very few of you have actually downloaded the training set that model was trained on. Right? So you don't actually have access to the training distribution. These models are trained on the whole internet, but you haven't actually looked at the data that's in that training distribution. Then one implication of that is that the production distribution, so the data that comes from your end users for the tasks that they want to solve, always looks different from the data your model was trained on. Right? If you're building an app to ask questions from your Notion database, there's no way that OpenAI trained their model on mostly data that looks like that. Right? The data is much more diverse. So in traditional ML, so the implication of this is that it doesn't really make sense to think of evaluating large language models as taking a big sample of data from a data set that we know about and computing metrics on them. But in addition to that, the metrics themselves are really different. So in traditional ML, you might have a metric, like you might be trying to classify whether an image is a prediction of a cat or a dog. And the way you do that is you look at your predictions, which ones are cats and which ones are dogs. And then you look at your labels, so which ones are actually cats and which ones are actually dogs. And then you compare those things, and you compute a metric like accuracy that says, how often was the model right about this prediction? In generative ML, like in a lot of the things that you all are doing with large language models, your outputs, like your predictions, might be a sentence. So the sentence might say, this is an image of a tabby cat. If your label says photograph of cat, how do you tell if that's correct or not, right? Is that a good prediction or is that a bad prediction? Maybe it's a good prediction, right? Because it's actually even more specific than the label. But maybe it's a bad prediction because you don't want this model to return the specific type of cat that this is. You actually just want to say that it's a cat. And so the metrics that we use, the numbers that we use to compute to tell whether models are working in generative AI are ambiguous. So it's hard to quantify whether performance is working well or not. And the last reason why this framework doesn't work very well for LLMs is that oftentimes when we're building, in traditional ML, we're usually building a model to solve one use case. Like I'm building a model to classify images of cats versus images of dogs. In LLMs, the general assumption is that you're building technology that's pretty general purpose. You want this same model to be able to answer questions not just from your Notion database, but also from your Slack and from these other data sources. And not just questions about like payroll, but also questions about sales and marketing and accounting. And so the diversity of data is much more diverse in many generative ML applications than it is in traditional ML. And so the problem with that is that, let's say that you have a model where you have questions about startups, dogs, food, and physics. And your model is like really, really good at answering questions about startups. And it's pretty good at answering questions about dogs and food. But it's terrible at answering questions about physics. Is this a good model or is this a bad model? How many think this is a good model? A couple. Anyone think this is a bad model? Okay. People don't have an opinion. The question is, obviously, it depends, right? It depends what you need this model to be able to do. And so it's really, really hard to summarize the performance of a language model with a single number because the types of things that we're asking it to do are very diverse. So just to summarize, why doesn't traditional evaluation work well for LLMs? Well, they're trained on the internet, and that means that there's always drift. Your evaluation data is always different than your training data. And so drift actually doesn't really matter. It's qualitative. So if you're generating text as an output, it's difficult to come up with a number that measures success. And there's a diversity of behaviors that you often want from these systems. And so looking at aggregate metrics is just not that useful. So I think the way you should think about testing LLMs is there's kind of two hard questions that you need to answer. You need to answer the question, what data are we going to evaluate this model on? And then you need to answer the question, what metric are we going to compute on that data? So let's talk about those. First question is, what data do you evaluate the model on? I think there's, and the summary is that there's like kind of 4 steps here. So the first thing that you want to do is you want to start incrementally. Then you want to get some help from AI. Add more data as you continue to roll this thing out. And then I have kind of like an idea that I want to throw at you of something that I think might help make this more principled, but is a little bit ill-formed. So we're going to start incrementally. And what does this mean? So this means that as you're starting to work on your model, you might be like writing your first couple of prompts. It's okay to start by evaluating your model in a really ad hoc way. So let's say that I have a prompt template that's like, write a story about a given subject. I might just play around with this and try out a few subjects that I think might be interesting for it to write a short story about, and just see what the model does in response to those inputs. As I find inputs that are interesting in some way, so where the model does something wrong, or where the model does something really different than I saw before, then I'll start to organize those examples into this like small data set of examples. And so now, rather than having to type in dogs or LinkedIn or hats every single time I make a change to my prompt, now I have this like little data set, and I'll just run my model against all those examples, and I'll just see the outputs side by side in parallel. Quick aside, what does it mean for an example to be interesting? I think usually either that means it's hard, so it like caused your model to do something bad in the past, or it's really different. Like hey, I realize that I actually need this model to work well on LinkedIn posts as well as marketing emails, and those are very different, or maybe not. Second piece of advice here is use your LLM to help. So oftentimes, we don't actually have this data set of examples that we can start out with. And so the nice thing about using LLMs is that they're really good at generating text. And so maybe not so surprisingly, they can help you generate test cases. Here's an example of a prompt from this auto evaluator library, which generates some question answer pairs for a QA environment. And I'll show you an example of doing this in Gantry as well in just a second. So we've started with this really simple data set. We've used our LLM to help us bootstrap more examples. And then I think the most critical part of this is to build your data set incrementally. So as you roll out to more users, then add more data to your evaluation set. So what data should you add? Well, you should look at things that your users dislike, maybe things that if you have annotators that they disagree with or they don't like. You can look for data where another model disagrees with the model that you have in production. You can look at outliers relative to your current evaluation set, or underrepresented topics in your data set. So these kind of break down to this category of data that's hard for your model, so things that people don't like. Your model didn't do a good job, according to the people that are looking at this thing, or data that's really different than what you currently have in your evaluation set. So it might be helpful to see how future models perform on that. Okay, one thing you might be feeling looking at this is, doesn't this feel a little arbitrary, right? Doesn't it feel kind of weird that we're just picking examples that we think are interesting, adding them to an evaluation set? Isn't there a more scientific way to do this? So is there any way that we can quantify how good our evaluation set is so that we can progress towards having a better and better evaluation set? I think there is. I'm not going to cover the details of how we do this in this talk, but if you're interested, come talk to me after. There's some math involved. But the high-level idea is we can formulate a notion that that looks something like the traditional test coverage metric, but for AI. And the way that you would want this to work in principle is you would want to have a metric where if your production data has a lot of data points that are really, really far away from anything in your test set, then that should be like a low test coverage data set, right? Because you have a lot of production data points that don't look like anything in your test data set. On the other hand, even if you don't have that many test data points, but there's nothing in your production distribution that is really that far away from any of them, or from at least one of them, then you would want that to be a high test coverage data set. So I won't get into the math here, but this is some intuition about how we might be able to quantify whether your evaluation sets are good or not. Maybe last thing I want to talk about on evaluation metrics is, how do you pick, or on evaluation is how do you pick the metrics that you want to use? Here's a flow chart that you can walk through. The first question you might ask yourself is there a right answer to this problem, right? If you're predicting whether something is a cat or a dog, there might be a right answer. And if there is, you can just use the same evaluation metrics used in traditional ML. If not, then the next question you can ask yourself is, do you have a reference answer? Do you have an example of what a human, or a human that you trust, would say in response to this? And if there is, then you can formulate metrics that involve matching the generated example from the LLM to the reference example from that trusted human. If you don't have access to that, or if it doesn't make sense for your problem, then you can look at comparing the new output of the model to a previous answer generated by an older version of a model, maybe one that you have reason to believe is at least okay. And so you can formulate metrics that answer the question of which one of these things is better. And then finally, if you don't have that, so if you don't have which means that it's going to be really difficult for you to compute an automated metric on top of your system, then you can look at previous examples of humans that provided feedback on older examples from the model, and you can compute metrics based on whether the feedback is actually incorporated into the model or not. So one point I want to make here is this traditional eval metric. That's just some math that you can do, like accuracy. You can just compute a number using Python, scikit-learn, whatever you want. The rest of these are all metrics that involve using a large language model to evaluate another large language model. So the way that all the rest of this tree works is you ask an LLM like, which one of these answers is better? Or, did this answer incorporate the feedback from the previous answer? So, really surprising fact that LLMs are actually reasonably reliable evaluators of the performance of other LLMs. And this is especially true if, you're using a smaller LLM in production and you're willing to, pay the big money for GPT-4 to evaluate it offline. Okay, so I'm going to skip through this. And I'm going to come back to, let's try to make this a little bit more concrete. So let's talk a little bit about Gantry. So Gantry is basically, we're building a product that helps you run this process, this test-driven development process, on your, for your own applications. So I won't go through the details of this slide, but basically, high level, this whole workflow that we talked about, like finding feedback on your model, using that to iterate on the prompts, evaluating it systematically, approving the changes, and promoting that to production, we have features that sort of line up with each of those. I'll show you what those look like in our UI. But it's also worth noting that there's sort of ways to do each of these things that I'm going to show you in code as well. And lastly, a couple principles that we've had when building this. So we're really big believers in the value of human feedback at Gantry. It's, at the end of the day, ultimately, whether models are working, it's a question that you're asking, are they solving the problem for your end users? And so we really believe in incorporating feedback from end users. We're also really focused on collaboration. So we found that a lot of these LLM-powered products are getting built not by engineers, but by interdisciplinary teams of engineers, product managers, other stakeholders. So we're trying to help those whole teams come together to build this stuff. And then lastly, and maybe the one that's the most fun is, we looked around at a lot of the tools in the LLMOps space, and it's kind of funny, a lot of you who are building LLM-powered product features, you're building these amazing, magical product features for your end users that are powered by this brand new technology to solve problems that they couldn't solve before. But the tools that you're using may not actually incorporate that same sort of modern AI first approach. And so we are looking for as many ways as we can to incorporate AI into the process of building AI. So let me show you what that looks like. And Carol, do you mind? Yeah. Cool. So you can write this prompt in code and upload it, but it's a little easier to do in the UI. So maybe an initial prompt I might start with is again, we're trying to correct grammar of user sentence. So let's just ask the model, correct the grammar. And we're going to actually have to pass in the user's input. And so we'll do that as a prompt template.
If you listen.
Yeah.
Scroll it list. Yeah.
Okay. Yeah. And so let's just test this out on a couple of examples to see if this does something reasonable. So let's say, we went to the store, and then, I don't know, we go to the store. I'm getting really good at writing bad grammar sentences from doing this demo a bunch of times. And yeah, it seems like it's doing something reasonable, right? But how do we know that this is actually performing well beyond just those two examples that I just kind of made up? So what we can do is we can take a look at this version that we just built, and we can evaluate it. So again, two pieces of an evaluation. Where do we get the data from? And then how do we actually define metrics on that data? So our approach at Gantry for both of those is to use LLMs to help us. So we're going to generate a data set that we can use to evaluate this. And so yeah, grammatically incorrect sentences is kind of what I want here. So I'll hit generate data. And this is hitting OpenAI to generate some example data points that that we can use to evaluate whether this model is doing the right thing. And yeah, yesterday they walked to the store, a bunch of examples that don't have great grammar. So we'll name this our eval data set. So now we have some data to evaluate on. Next thing that we need to do is we need to actually define the metrics that we want to evaluate on this data. And so in this case, really what we want to know is whether the outputs are grammatically correct or not. And so that's our evaluation criteria that's going to be passed to another LLM to do the evaluation. So this is now running. It'll take a few seconds as we wait for OpenAI latency. But what's happening in the background is it's generating, for each of those inputs, it's generating an output from our model, and it's scoring that according to another LLM. And maybe not surprisingly, this kind of simple prompt for these simple inputs that we developed, it's performing pretty well. The model thinks that 100% of these inputs are 5 out of 5, right? And if we kind of eyeball it, it looks like that seems pretty reasonable. Me don't like broccoli, I don't like broccoli. That's a pretty reasonable correction. If we want to kind of know why the model thinks that's the answer, we can just kind of zoom in and inspect its chain of thought that it came up with for answering that question. So real world, we probably would want to like iterate more on this prompt to make sure that it works reasonably well before rolling it out, but this is a demo, so we're going to YOLO it into prod. So this is now in prod, and what does that mean? What that means is that this is tagged, this prompt is tagged, and you can now pull this prompt from Gantry CMS to use in your applications. You can do this in a couple of different ways. I'm going to show you kind of the easiest way to do it, which is to do it just by calling our proxy. So what that looks like is I have like a really simple Streamlit app here. Zoom in. And rather than calling like OpenAI completion endpoint, instead we're just going to call a similar completion endpoint from Gantry. And instead of passing in the full prompt as well as all the model parameters and all that kind of stuff, instead we're just going to pass in that input that we wanted to send to that model. And Gantry is going to pull the latest prompt version, latest model parameters. It's going to complete that prompt template, send it to OpenAI, get the response back, and then log all the results back to Gantry. So other ways to integrate, this is the simplest one. If we run this Streamlit app, this is really small, but it's okay. You don't need to see this part. And then we open this up. Then yeah, this is like maybe what your end users would see, right? So we've got a text box that you can write sentences in. This sentence has good grammar. And then they can submit it, get a response back. That seems pretty reasonable, so they can give like positive feedback on this. So rather than like doing hundreds of these, I pre-sent a bunch of data to this application. And what we get and as a result of that is we get this like kind of nice dashboard that tells us like, hey, here's what's going on as your end users interact with this model. So we see some high level statistics here, like how much are they spending, what latency are they experiencing and things like that. But we also see, like what feedback are they giving, kind of interesting statistics like that. But then we also see a bunch of derived properties of the inputs and outputs, like what was the sentiment of the inputs the users are sending into the model? What was the sentiment of the responses the model sent back? How toxic are they? How fluid are the outputs, and what language are they in, right? And so one of the really powerful things about Gantry is that we allow you to compute like all of these different derived properties of the inputs and outputs to your model in our infrastructure, so you can just like iterate on them really simply just by writing Python functions. But these are the ones that we have right now. And so one thing I notice here is that there's a bunch of inputs that are not in English, so that's kind of weird. So if I filter down on those, what I see is, so some users have been submitting some text in French. And for the most part, like these, I don't really speak French very well, so I have no idea if it's getting the answer right on these. But there's some where it's like actually translating the French to English. So that doesn't really seem like the behavior that we want, right? So let's grab these data points. And coming back to like our test-driven development philosophy, what do we want to do? Well, we want to add these data points back to our data set so that when we evaluate the next version of our model, we can test it and see whether it's improving its performance on these data points where it failed in production. So all these to our eval data set. And if we go take a look at this, now it has like kind of the 10 original examples that we had, as well as these 4 examples in French. Next step here is, let's see if we can fix this problem. So I'm going to try to do some like live prompt engineering here to fix this issue with the model. And so I'll add another version. And rather than just like correcting the grammar of the user's input, I will tell the model, make sure that your response is in the same language as the user's input. Now, I'd probably, if I had more time, I would do a more careful job of prompt engineering than this. But for now, let's just run this and see if it does something reasonable. So it does not. Interesting. Well, yeah, let's, maybe we need to give an example of the live prompt engineering. It's very, very stressful. Let's see. Example, like follow the example format. This is a good prompt engineering trick for those of you who are learning prompt engineering. User inputs. Oh yeah, bracket. Thank you. Aha. All right, live prompt engineering. Okay, yeah, so now it's doing something more reasonable, right? So now is this working? Next thing we're gonna do is we're gonna take this new version that we just developed and we're gonna evaluate it. And so now we have a richer data set to evaluate it on. We have versions to compare it to, and we can add another criteria here that says like, results should be, this is like an awkward angle to type at. There we go. And let's run this and see what happens. So sometimes it takes a little bit longer to run. What's happening in the background here is model's taking these 14 inputs. It's running both of these versions against those inputs. It's taking the outputs. It's scoring both of the outputs according to this evaluator model. And then it's going to give us comparison to tell us whether this model actually fixed the problem or not. So while we wait for this to run, are there any questions?
What model are you using for evaluation?
For evaluation, we're using, I believe, 3.5 for this, because it's, 4, it takes a long time for live demos. But 4 is probably what I would use in production. Yeah.
Are these versions also behind the scenes on are these running behind the scenes on also GPT 3.5? Like, is version 1 version 3, or this is a...
I believe, we can go easily check that. So I believe what we did is, I just used Text DaVinci just kind of as a default, and because it also fails more, which makes it easier to do this in a quick way. Okay, I'll take more questions in a second, but meantime, we've got our evaluation report. And interesting, so there's one example where V3 was better and one example where V1 was better. So if we kind of look down at those, it looks like actually, the prompt engineering that we did for version 3 here fixed the problem for one of the examples, but it did not fix the problem for one of the other examples. So I failed at my my prompt engineering test. But this can give you an idea of how you can do this in a more iterative way, where you make these changes to the prompt, you run an evaluation, and now I have feedback from this evaluation that tells me hey, I need to go back and keep working on that prompt because I ran it against all of the examples I care about and it didn't really improve performance. And so that's kind of the core workflow that we're trying to support, and really the way we think that that folks should think about building applications on top of LLMs. So yeah, I'll pause there. And while we take questions, I will also flash a QR code here. We are going to give everyone here early access to this product. So we're kind of doing a sort of quiet alpha of the product right now, building a lot of exciting stuff on top of this. If you use this link, then you should be able to just sign up and try the product for free. Our only ask is just give us a lot of feedback in the alpha. You can drop in our Discord from the products, and would love to hear what you think. Great. Happy to take questions. So, repeat them for the recording. Okay, sounds good. Yeah.
Methodologies. I thought you just let's think Josh framed this one of the principles with better models come from human feedback. Who is the human here?
Great question. It could be anyone whose opinion you care about the model. So, so who that is depends on where you are in the development cycle. If it's day one and you're working on this model by yourself, then you're the human. You're the human that gets to give the feedback on the model. If it's day 5, right, and you have your prototype and you're ready to share it with your team, you're ready to share it with your friends, those are the people who you should be gathering feedback from. When you roll this out into production, to all of your end users, those end users are usually the people giving you feedback. And then in a really steady state, once the product is mature, most teams end up building kind of a QA team to be the sort of professional evaluators of these models, because it turns out it's very difficult to perform better than GPT-4 on evaluating example outputs. So oftentimes you need professionals. Yeah, over here.
You're going to repeat the question for the recording, but Mike is softly. Do you hear me? Yes.
I can hear and just repeat from, yeah.
Looked like the unit of evaluation was a prompt. And the workflow you showed was improving the prompt, re-engineering the prompt. What are other changes that Gantry supports, either at the model level or what's fine-tuned, that like would set up a new version that you'd want to run all of your different.
Yeah, so it could be a different model, a different base model, right? You could pick a model from a different model provider, a different, you could see if the trade-off of, reducing cost by switching to a cheaper, faster model is worth it. It could be changing the chain. So we're going to support chains in a few weeks. And then for fine-tuning, we do have some tools to help with that, but that isn't as baked into this product experience yet. So fine-tuning is more finicky, and my general advice to folks is not really to worry about it until you really need to. Yeah.
So we were trying auto-evaluator. We were trying auto-evaluator before this. I think one of the factors is the accuracy of the evaluation model. The accuracy of the evaluation model can impact the accuracy of my test. So how does Gantry take that into account? Because it's essentially when you have a prompt inside that's trying to measure the accuracy of my prompt. So how does that work?
Yeah, so the question is, if you're going to rely on models for evaluation, then those models themselves need to be accurate. How do we deal with that? So two points there. One is we drink our own medicine. So we also are building sort of hooks to gather feedback from our end users on how the evaluations are working. And behind the scenes, we're using that feedback to make our evaluation models better. And so that's sort of the magic of the way that we're developing this product. One point that's kind of hidden there is that I don't really think that my recommendation is not to replace human evaluation with automated evaluation. I think that's misguided, because ultimately, the whole reason why we need evaluation is because models are unreliable. And so at the end of the day, you want someone who is on the hook for saying, yes, these results are good. The way I think automated evaluation is really useful is for two things. One is for faster iteration. So if you're working on this by yourself and you want to just get a quick sense for whether things are moving in the right direction, automated evaluation is really key. And then the second is to reduce the cost of manual evaluation. So in the post GPT-4 world, to do better than GPT-4 at evaluation, you're not going to be able to just find random people on like mTurk. They generally, numbers I've heard are something like 85 or 90% of Turkers are worse than GPT-4 at most labeling tasks, right? So let that sink in for a second, but it's pretty crazy. And so what that means is that if you really care about like quality assurance for your models, you need to train people to do quality assurance for the specific task that you care about. And you need to make sure that those people are better than the models that they're evaluating. And so I think the implication of that is that quality assurance and human evaluation is becoming more and more expensive, which makes sense when you think about it, right? Because as the models get better, the sort of judgment that you need to apply to their outputs becomes more and more specialized. And so the role of automated evaluation beyond just iteration speed is, I think we should try to use automated evaluation to reduce the number of data points that humans need to look at, and focus on the data points where we need to spot check the model, where maybe we're most uncertain about how the model is performing on this data point. Question here, yeah.
So in your example, you've been using one metric to evaluate all observed performance. I'm curious, what's your recommendation when you have multiple metrics, multiple objects? Do you propose to collapse those as a fund for the
Yeah, I think it's better to split out multiple metrics. And so you can define a weighting across those metrics if you want to have one number to look at. But I think it's better, you really want to look at how model performs on each of those metrics. And really even more granular than that, like each of those metrics across each of the different sort of slices of data that are important to you and your problem.
I'm just curious that if there are cases where they need in the same model that's actually first one with the generation of the machine. Maybe the generation part, the prompt has not been well defined. And are there cases where like the same model can evaluate different prompts on themselves and say that one is better?
Yeah, so surprising fact, but true fact, GPT-4 is pretty good at evaluating GPT-4 prompts. So it's if you want some intuition about why that is, when you're generating tokens as output from a language model, the model can only really think one step ahead. So this is why like chain of thought prompting and things like that work so well, because you're giving the model a scratch pad. You're giving it like some tokens to use to think before it's forced to spit out the final answer. So like another, easy, like free prompt engineering trick is if you're trying to get a structured output, like always return this word, then you should always tell the model to return that at the end, not at the beginning, because then it's had time to think before it returns that output. And so the reason why automated evaluation works, or the intuition about why it works, is kind of similar, which is that the model's thinking on the fly to generate the output, but then when it's evaluating the output, it has the benefit of hindsight. So it has the ability to look over the entire sequence, incorporate that into its decision about what's the right thing to do or not the right thing to do. So there is some evidence that models have some bias towards the output of their own evaluation, the outputs of themselves. One thing that might not work that well is if you wanted to use GPT-4 to compare, GPT-4 and Anthropic. You might get some bias there, but there's ways around that we're working into this. Yeah.
You mentioned that there's no focus on fine tuning, but I don't know if you're familiar with Vicuna, for example. It was fine-tuned based on GPT-4, and as a result, it got much better results than the others with the small set of prompts. So just wanted to hear your perspective on fine-tuning.
Yeah, no, I think fine-tuning is making a comeback. I think open source LLMs, I'm really excited about them, and we will support them, just not supported right now. Yeah, fine-tuning is kind of itself a difficult problem, and so that's just not been our focus up to this point. Any other questions? Cool.
Yeah. So, it's a interesting question. So, do you think open source or private LLMs will win?
Both. Yeah. I think this is going to be such a big category. Like all approaches are going to succeed. Proprietary ones are always going to be, highest quality and the easiest to use. Open source has obvious advantages. You can deploy it on-prem. You can customize it a lot more easily. Both approaches are going to succeed. Yeah, it's kind of like, Mac versus Linux or something, right? Which one won? Well, people make a lot more money on Mac than they do on Linux, so maybe Mac won. But Linux is installed on a lot more devices, as far as I know, so maybe Linux won. Great. Well, yeah, thank you all so much for coming.